I welcome you all in the next part of the biosynthetic pathways. So in this video we are going to cover, again we will going to revise shikimic acid pathway. As you can see here, shikimic acid pathway, it will produce different type of aromatic amino acid, okay, and from this we have produced different type of metabolites like alkaloids. It also directly producing tannins and flavonoids. Let's see how. So we know shikimic acid pathway, it will starts with this erythrose 4-phosphate, and this is obtained from the pentose phosphate pathway, and this phosphenol pyruvic acid is produced via glycolysis, and it upon aldol condensation it will give this compound, that is the keto. You can say this glucoheptonic acid. You can count here 1 2 3 4 5 6 7, 1 2 3 4 5 6 7. So this heptonic, you can say the glucoheptonic acid is produced, and this will undergo again this phosphorylation, or you can say the removal of this phosphoric acid, or you can say dephosphorylation, because this group is removed here, that is the phosphoric acid group is removed, and via cyclization it will form this compound, that is the 3-dehydroquinic acid. And from this compound, that is the 3-dehydroquinic acid, you can see here via dehydration, okay, via dehydration what was happening here, 3-dehydroshikimic acid is produced, and from this 3-dehydroshikimic acid, look at this structure, this is 3-dehydroshikimic acid. What is producing? Shikimic acid. And what is the reaction? By reduction, you can say this is double bond O, here it is, wait a second, this is OH. Okay, again look, double bond O, it become OH. So via reduction it will produce this shikimic acid. And now what happening here, shikimic acid, it will undergo phosphorylation and elimination reaction. Mainly two reactions are there, phosphorylation and elimination reaction. It form an important intermediate that is known as this corysmic acid. So this corysmic acid, this is an important substrate, you can say, for this anthranylic acid, and it will convert, that is the corysmic acid, it will convert into anthranylic acid with the help of anthranylate synthetase. Though here it has an enzyme is used, that is known as the anthranylate synthetase. Okay, and finally it will produce the aromatic amino acid, that is a tryptophan. Okay, and how it is produced? There are number of reactions are there. Here two symbols mean there are different type of intermediate reaction, but you have to remember only this. And if you look over here, this again corysmic acid, again it by a simple rearrangement it will give this prephenic acid. And what was happening here, this prephenic acid on dehydration and decarboxylation, it will finally yield this phenylalanine amino acid. And here also, and here on dehydrogenation and decarboxylation reactions are working, and this will convert this prephenic acid into this beta hydroxy phenyl pyruvic acid, and this is the direct precursor of tyrosine. So again amino acids are produced. So what was happening here, from shikimic acid, amino acid, or you can say aromatic ring is there, so that's why it is known as the aromatic amino acids are produced. So we can say that through shikimic acid we found tryptophan, phenylalanine and tyrosine, and these further resulted into the production of the metabolites, because we have not yet see how the metabolites, or you can say the primary or secondary metabolites are producing. Now if you look at here, as we know, phenylalanine and tyrosine, they are produced by this shikimic acid pathway, and with the help of this aromatic amino acid, that is phenylalanine, ephedrine This is an alkaloid, proto-alkaloid. Ephedrine is producing. So these are the, this particularly figure shows the production of the secondary metabolite by using different amino acid. So ephedrine is produced by which amino acid? Phenylalanine. And you can see here tyrosine, which is produced again by shikimic acid pathway. It will produce papaverine, okay, which is again an alkaloid. Morphine, codeine, thebaine is there. Then dihydroxyphenylalanine produce amytine and colchicine. So basically this shows the production of alkaloids by different type of aromatic amino acid. Okay, that's why it is written here, some alkaloid derived from phenylalanine, tyrosine and their derivatives. And if you look here, look at this shikimic acid, again it will produce cyanidin and quercetin. So these are the flavonoid derivatives. I hope you remember about the flavonoids also. So what was happening here, the shikimic acid will produced with the help of different type of units, that is malonyl coenzyme, or you can say acetyl coenzyme. C15 intermediate is produced, and I hope you remember about the flavonoids. These are C6, C3 and C6 skeleton. Means these are 6 plus 6 12 plus 3 15. So these are 15 carbon skeleton, that is the flavonoids. And yes, they are classified into various categories. This is not our concern now. So what I am trying to saying is shikimic acid, it will produce different type of amino acids, and through these amino acids, that is aromatic amino acids, we produce different type of secondary metabolites. Just see here, shikimic acid, it resulted in the production of flavonoids. Yes, we have seen it will produce alkaloids via aromatic amino acid. We have also seen this. So I hope this is clear now. This is the shikimic acid pathway we have covered. So as you can see here, again we are repeating, this shikimic acid pathway starts with the erythrose 4-phosphate that is obtained via pentose phosphate pathway, and this phosphenol pyruvic acid is obtained by glycolysis. And these two combines and they will go aldol condensation to yield this glucoheptonic acid. Okay, and this molecule again undergo phosphoric, we can say the removal of the phosphoric acid or dephosphorylation or plus cyclization to yield this, that is the 3-dehydroquinic acid compound. And this 3-hydroquinic acid undergo dehydration, okay, dehydration to form 3-dehydroshikimic acid, which yield shikimic acid by reduction. See, concentrate here, reduction. Okay, and then we know this shikimic acid through phosphorylation and elimination reaction form an intermediate that is known as the corymic acid, or you can say corymic acid. This corymic acid yield this anthranylic acid with the help of anthranilate synthetase, and finally tryptophan, which is an aromatic amino acid, is produced. And over here again this corymic acid via simple rearrangement give prephenic acid, and prephenic acid on dehydration and decarboxylation it will yield phenylalanine over here, and upon dehydrogenation and decarboxylation it will yield this tyrosine. And after the production of these amino acids, suppose tyrosine is produced by shikimic acid pathway. So tyrosine resulted in the production of different type of metabolites, like in this case alkaloids are produced like papaverine, codeine, morphine and thebaine. And phenylalanine is producing ephedrine and mescaline. These are also the type of alkaloids. And over here shikimic acid is directly producing this C15 intermediate, which then produce different type of flavonoids derivative. So I hope this will give you a brief idea about the shikimic acid pathway resulted into the formation of the secondary metabolite. So we have completed the production of secondary metabolite via this shikimic acid pathway. So thank you for your patience and listening. We will do the acetate pathway in the next video tutorial. Thanks.